Well, in today's class, we are going to discuss about assessing alternative architectural designs. What it is? It is about assessment. What we are going to assign. What we are going to assessing or studying alternative architectural designs. Here we are going to assess the architectural designs. Okay, for a single problem, how many designs we have? So among the multiple number of designs, okay, which one is the best design? How to choose the best design among multiple number of designs for a single problem, right? So in this unit till now we have discussed about design styles, design concepts, how we are going to made some design styles based on a project. So among the multiple number of styles or multiple number of designs for a single problem, okay, how we are going to tell which one is the best design for a particular problem. So that is the concept here, assessing of the alternative architectural designs for a project, for a given project here. So first of all, to evaluate the quality of an architecture, if you want to evaluate a quality of an architecture, then the design should be accomplished effectively. If you want to measure a quality of a design, so quality of a architecture, how to measure? Before going to measure the quality of your architecture, first of all you should finish off your design completely or successfully. Okay, we must complete the design to that particular architecture. Later we are going to evaluate that design, okay, to check the quality of that architecture or to assess that particular architecture, isn't it? If every design is completed, then only we can assess or we can evaluate that one, whether that is suitable to our problem or not, like that, suitable to our project or not. Without completing the design, how do we know whether it is fitted to our problem or not? We don't know, no? So that's why, first of all, how many number of designs you have, okay, ensure that all the designs are completed once or not. After confirming that, we would go for assessing each and every design. After assessing the designs, then we can find which one is a better design to our project or problem. Clear? So basically, there are three different approaches. There are three different approaches for the analysis of alternative architectural designs. Here we are having three different approaches. It's not a single approach. We have three types of approaches are there. Okay, to assess the uh, designs. Which one is best one to assess the designs here? What are those? First one is ATAM. The first approach is ATAM, means architecture trade-off analysis method. Second one is architectural complexity. Third one is architectural description language, ADL, architectural description language. These are the three different approaches, okay, to find out the best design, to find out the best design among multiple designs for a single problem. Clear? Let us discuss one by one. What is the first one? First one is ATAM. This is about the first one, ATAM method. This ATAM method was developed in Software Engineering Institute, SEI. This is Software Engineering Institute has developed, okay, an ATAM for design analysis activities. Okay, if we want to analyze the if you want to analyze the design, then we should follow the below steps. What is the first one? Here we have collect collect scenarios. So for each and every problem, okay, we are going to develop collect scenarios. That is the first one. For each and every problem, we are going to develop some scenarios, which means it is in the form of use cases. So use cases are developed to represent the system from user's point of view. How user is going to interact with the system. So what transactions he is going to perform with that particular system. How he is going to interact with that. So everything we are going to, okay, we are going to present in the form of use cases. Here we should collect all those use cases or all those scenarios, right? Next, in second step, we are going to perform elicit requirements, constraints, and environment description. Okay, so then later in second step we are going to collect the requirements, okay, whether that developed design is, okay, based on the stakeholders requirement or not. Okay, to assess that we need to collect the requirements whichever whichever what addressed by the clients. Okay, and what are the conditions, okay, they told to us, and also which kind of in which technology they were asked us to develop this particular project. Okay, by using which technology we should build this particular project. So like that certain rules and regulations whichever taken from a stakeholders, we should check and match with these scenarios, right? And coming to the third one, okay, describe the architectural styles or patterns. So how many number of architectural styles we have to address the scenarios and requirements. So according to a customer requirements, how many existing patterns are available to implement uh, uh, this particular project. Okay, like that we need to describe styles or patterns whatever available in real time. Okay, so that is about suppose module view or process view or data flow view. Right, here we are going to describe instead of by using, I mean in the form of module, individual module. A project may be divided into the number of modules. Okay, how the module uh, how the module would describe what is the function of a module here, how it is going to execute the things, and what is the data flow of that particular tasks in what functions in that particular module. So you should describe each and every module individually. Coming to the fourth step, evaluate the quality attributes here. Evaluate quality attributes here. So what are the quality attributes are are added into this particular project towards reliability of the project, performance, security, maintainability, and some other portability, reusability, or interoperability. So these are all the different what quality attributes. So how many number of quality attributes are included into this particular project or added into this particular project? Okay, by adding these quality attributes only, we can what achieve the, or we can build the qualitative project, isn't it? Qualitative outcome. So what is the reliability here? Reliability in the sense the particular project or app would work without any kind of disturbances. Okay, without any kind of disturbances throughout the multiple number of years, without getting a false while working with that particular project or something. Okay, this kind of all the things are coming under the quality attributes. First of all, evaluate those quality attributes. How many quality attributes are added into this project? Whether those all quality attributes are suited to this particular project or not. Okay, if anything we need additionally, like that, here we need to evaluate those quality attributes in fourth step. Coming to the fifth one, identify the sensitivity of quality attributes, which means is there any specific, okay, specific attributes are there, those are very sensitive attributes, which means if something has been changed or attacked, that particular part is affected or overall the project is affected, overall project is affected. Okay, so such kind of things coming under a sensitivity. If we will change one value, or if we will change one particular small part of a function, then it would affect the overall project or overall module, in the sense it is a very sensitive, okay, variable into that particular project. So be careful while defining those kind of variables in a function. So how many number of sensitive variables or sensitive attributes are there in our project or not? Check out that those things. Okay, identification, right? So sensitive attributes in the sense, if we will modify or we will edit that particular data of that attributes, then it may affect the okay, multiple places of that particular project or multiple parts of that particular project. Okay, that is called the sensitive attributes. After that, the sixth point is, okay, critique you candidate architecture using the sensitivity analysis conducted. So um, after identifying the sensitive quality attributes, Then, okay, better to not change the things or attributes, or if something is if we want to increase our performance of that particular project, what we have to do there? Better we would we can use the high end systems. If we can use the high end systems into with our project, then automatically the performance of that project would increased, isn't it? So this is also a one kind of sensitive thing in a particular project, right? Suppose if we have only one server, okay, with our project, so it can't handle the overall data whichever generated by a users. So what we should do, what we have to do in such a kind of situations? Then we are going to increase the servers. Instead of one, we may use two or three or four. Then it is easy. It is easy to handle the data, isn't it? So it won't give the state of busy or something. Okay, to overcome such kind of things, better first of all we should identify the what are the sensitivity things in our project. So how to handle that? If those sensitive things are I mean towards towards a performance of that particular project, in the sense, better to, okay, increase the better to increase the performance of that particular project by doing whatever we have to do at that place, right? This is about the sixth point. Okay, if you analyze the project by using these 6 steps, okay, not only one, what how many number of designs we have, so check all the designs by using these 6 points. If you will go through by using these 6 points, this is called a ATAM method of analyzing the designs of a project. Clear? This is one kind. If you go for second method, what is the second method we have? Architectural complexity. The second method is a architectural complexity. So architectural complexity in the sense, the overall complexity of a proposed architecture is assessed. The overall complexity of a proposed architecture is assessed by considering the dependencies. First of all, if you want to assess a particular design or particular architecture, then you need to calculate the complexity of that particular project. Complexity of that particular project. In general situations, you may say that complexity towards time and space. If it is a code, then we are going to calculate the complexity of that code in the form of, okay, by calculating the how much space the program is needed. Okay, if you want to save that particular program into a computer memory, so then how much space it is needed, that is a space complexity of that particular program. At the same time, how much time it is taken to execute or to give the output, that is called a time complexity of that program, right? If we have the two programs, okay, for suppose if if I have conducted a test on particular question, which means I have given you one question, write a program for so and so purpose, like that. Okay, 60 members, 60 members have written that program, right? So among the 60 students, 60 members, how I'm going to check the complexity of that particular program? Which one is the best? Which student program is best for my question? Okay, so I'm going to assess your 60 programs based on the time and space, whether it is giving correct output or not towards my program. That is first point. Second point is how much space is needed to save this program. Third point is how much time is needed to execute that particular program. I'll take the consideration into these 3 points. Based on these 3 points, okay, I would say which one is the best program, who written that best program, right? So like that, here also, here also in design, we are going to calculate the complexity. Till now I have discussed about a code complexity, I mean programming complexity. But now in this concept, we are discussing about the design complexity, which means architecture complexity. How do we find which one is the best one? Based on the complexity, which means architectural complexity is assessed by considering the dependencies between the components within the architecture. If you want to find out a architectural complexity, then what we have to do here? We need to consider the dependencies of components within the architecture. One architecture may have multiple number of components, isn't it? So one architecture may have multiple number of components. Then, so what is the dependencies of that particular components? Okay, when whether one component is dependent on another one or not. So by assessing this, okay, we are going to analyze the complexity of that particular design here. Complexity of that particular design here. So here we are having 3 types of dependencies. 3 types of dependencies here. First one is a sharing dependency, flow dependency, and a constraint dependency. Right. What is the first one? Sharing dependency here. The sharing dependency, in the sense, dependency represents dependence relationship among consumers, okay, who use the same resources, or producers who produce the same consumers. Okay, which means if there are, we have two number of components, component 1 and component 2 within a architecture, within a project. Okay, these two components are sharing same variables information or not. If those two components are sharing same variables data, then those components are having the sharing dependency. Those two components having the sharing dependency. For example, okay, here we have C1 and C2, two, okay, components. These two components may share the, okay, suppose here the variable a is there, a equal to suppose 20. Okay, assume this is my variable value. Okay, now c1, okay, this is one component and this is another component within a, okay, project. So these two components may use this a value. Okay, these two components may use this same a value. Then, okay, this is c1 and also this c2. Those two components share the same variable value a. C1 may use this a value and C2 also may use this a value. A is a global variable here. Then this kind of dependency between C1 and C2 is called the sharing dependency. So these two shares the value of A. That's why this relationship is called a sharing dependency here. And coming to the second one, what is the second one here? Flow dependencies. Okay, flow dependencies in the sense, if if this C1 may interact with C2 for some data or by passing some variables to C2. Okay, this kind of dependency is called the flow dependency. Okay, how these two are interacted? Either C1, okay, may communicate with the C2 component. How it is communicated? By passing some arguments or by passing some values to C2, or otherwise it produce some outcome. After finishing of this outcome only, we are going to start this C2. Then this kind of things, relation in between C1 and C2 is called a flow dependencies here, right? And coming to the third one is constrained dependencies. Constrained dependencies in the sense, so if if these two are not executed at the same time, these two are not executed at the same time, then such kind of components are called the, are under the constrained dependencies, which means suppose always C2 will be started execution after receiving the output of C1 only. Okay, so C2 is dependent on C1 output. Without the value, okay, without the C1 output, it can't execute or it can't execute its values. Then, okay, in such a case, we can't execute C1 and C2 parallelly, isn't it? This kind of situation is called constrained dependencies here. Suppose C1 is going to perform um, b equal to a plus c. Assume, okay, C1 is going to perform b equal to a plus c. Already it has the c value equal to 6. Now this C2 is going to perform the tasks of um, D equal, suppose Okay, G equal to B plus A. So this is the function the C2 is going to perform, right? Okay, so C1 needs to calculate B value, which means B equal to A plus C. Already it accesses the A value from here. Already it has some A value, that is 20. 20 plus C is already, it has some C value also. So C equal to 6. So A equal to, sorry, B equal to A plus C, in the sense it's total 26. 26 is saved into a B. So then next it will produce the output of 26 to C2. C1 produce the output of 26 to C2. Why? Because here it is C2 is going to calculate B plus A. Already A value is 20. It has 20 A value, but B value from which it needs to take the B value from C1 itself. So that's why 26 plus 20, it's around 46. G holds the value of 46. So always the C2 is waiting for a C1 response. So in this kind of situations, we can't execute C1 and C2 parallelly, right? So these kind of components, okay, are the constrained dependencies. Clear? So to now, so by performing these three dependencies test, then you may check which one is the best to design, right? To assess the design technique. Next one, third one is ADL. ADL in the sense, it's a architectural description language. So architectural description language provides a semantics and a syntax for describing a software architecture. So it provides architectural description language. This is the one of the technique of assessing architectural designs. Okay, this is the third one. So through this, how we are going to assess the architecture through this ADL, which means, okay, it provides some, okay, semantics and syntax for describing a architecture, and also, okay, it provides designers to it provides designers with the ability to decompose the architectural components. Decompose the architectural components. Now, after decomposing the total components, which means dividing the components, the total components of the architecture, then if one component is but a larger one, so you need to make it that one is a, okay, individual component. Okay, first, if you have one problem P1, okay, you can divide this P1 into a multiple number of parts, decomposition, which means P1, P2, P3, like that, P2 and P3, like that. Here you have decomposed the total, problem into a number of components. So among these three, if the P2 is a larger one, then you need to translate or you need to compose this one as a individual component. This particular P2 has a individual component. Then coming to the third point, represent interfaces between the components. If those components want to, okay, interact with one another, then you need to represent or establish a connection. or you need to, okay, make some interfaces between those components, right? This is the third one. This is the third one to assess the architecture, to assess the architectural design, right? All right. This is about our today's class.